A set is any collection of objects. These objects are called the elements in the set. For instance, the collection of the students in this class, that's a set. The collection of all the letters in the alphabet is another set. The windows in that particular building that face north, that's another set. We will say that each element belongs to the set. This is the notation that we use to say that an element belongs to a set or an element is in the set. We are going to be using a lot of mathematical notation in this class, and this particular one means then that an element X is in a set X. So, for instance, if the set X is the set of all the countries in the world, and the element X is the country Morocco, so we can say Morocco belongs to the set of all the countries in the world. New York does not belong to the set of the countries. And we are going to use the Venn diagram representation of a set that is simple, an oval or a circle with the name of the set. There are two ways to describe a set. We are going to describe by using roster notation or set builder one. Roster is when we actually list all the elements of the set, and this will be the notation for that. You put the name of the set is equal to braces, and so here start to list the elements and close the braces. So in this case, for instance, we'll have that this is the set that had the elements 0, 1. In a Venn diagram, we can put an oval and put the elements 0, 1 inside of the oval. And then this is the example of the set B that contains the elements 1, 3, 5, 7, contains these numbers, or the set X that contains these letters, the letters A, B, C, D, or this very particular set that is the empty set. The empty set is a set that contains nothing, a set that has no elements. The other way to describe the same set will be the set builder notation. This way to describe a set stating a property that characterizes all its elements and only the elements of the set. For instance, considering the set B given in roster notation 1, 3, 5, 7, could you describe the same set but without listing the elements, without naming the elements? Can you explain to me what elements are in B without naming them? Well, the answer is the description of this set in set builder notation. So you could say that the set B is actually the set of the natural numbers such that X is odd and X is less than 8. So think for a moment in this description. The natural numbers that are odd and less than 8 are exactly only the numbers 1, 3, 5, and 7. So we find a way to describe the same set without actually naming the elements. So that's what the set builder notation does. So we see in these examples here some other cases. So for instance, the set C is the set, see how I read this notation, the set of all the natural numbers such that are less than 2. So we can try to express that also in roster notation. This set in roster notation would be the set of the natural numbers smaller than 2, will be the 0, the 1, and nothing else. In the second one, the set D is the set of X such that X is a letter in the Latin alphabet. So we can roster them by saying this is A, B, C, D, all the letters of the alphabet. The set E, the set X, the set of X such that X is a country in the world. So we can picture what are all the elements even if they are not described one by one, so we can know exactly what is in this set E. The set Q, this is a very particular set, the set of the rational numbers that can be defined as the set of X such that X is equal to A over B, where A and B are integer numbers with the condition that B is not 0. Well, this is just the set of fractions, right? A over B, where A is an integer and B is an integer. And finally, this set, the empty set, which is the same one that this one, right? But it's defined in this other way. So in this way, the empty set is defined as X is a natural number such that is less than -5. Well, there are no natural numbers less than -5, so this is the same thing of a set that contains nothing inside, the empty set. We will say that a set A is a subset of B in case that all the elements in A are also in B. And this is going to be our notation. A is contained in B, or A is a subset of B. The equality of sets is a particular case of being a subset. We are going to say that two sets are equal when they have the same elements. In other words, the sets are equal if and only if A is contained in B and B is contained in A at the same time. Examples, we have here that the set of the numbers 0, 1 is contained in the set of the numbers 0, 1, 2, 3, 4, 5. So we see that all the elements in A are also in B. We see also here that the set 0, 1 is not contained in the set 0, 2, 4. Observe that any mathematical symbol can be denied by just crossing it. If this symbol means contain, means subset, A is a subset of B, this symbol means is not a subset. Same thing happens with the symbol equal, is not equal. Belongs, does not belong. We can see here that the set of natural numbers is a subset of the set of the integers, and here that the set of the countries in Africa is contained in the set of all the countries. And this particular formula here, the empty set is a subset of A. That will happen with any set A. The empty set is a subset of anything, no matter what A is. The empty set is considered a subset of any other set. We are going to say that a set is finite if its number of elements is n, where n is any natural number. That number is actually the cardinality of the set. So the cardinality is the number of elements that a set contains. So for instance, the set of all the countries in the world, how many elements have this set? Well, it has 197. There are 197 countries in the world. The set that have only these numbers here, 0, 2, 4, what's the cardinality of that? Well, it's 3. There are 3 elements in this set. And finally, this special case, the empty set. The empty set has no element, so the cardinality is 0. The number of elements that has is 0. And if the set is not finite, we will say that is then infinite. For instance, the set of the natural numbers is infinite. One clarification about the set of natural numbers, since we are going to be using this set again and again in this class, something that happens in general with a lot of terminology of discrete math is that it's not a standard. Many of the things that we're going to be talking about are used in mathematics and in computer science, and that's one of the reasons for which the notation and the meanings is not standard. So some people use it the symbols with some meaning and people use it with other meaning. So, before stating anything, you have to look at what in that textbook or in that context is considered the definition. So, in particular, the natural numbers is not always used with the same definition. Sometimes the natural numbers is considered the set of the numbers for counting, like 1, 2, 3, 4, all the way until infinity. This is in general the set of natural numbers. But sometimes is also added to this set the number 0. Especially in computer science, the set of natural numbers is considered to be this set, the set that starts at 0, and this is the definition that we are going to consider in this class, that the set of natural numbers is the set of the numbers 0, 1, 2, 3, 4, 5, all the way until infinity.